Nice to meet you. This is the Hobby IT channel. Thank you for watching today. In this channel, it is a video that challenges making things with IT. Programs and circuit diagrams are available on the website below, so please make use of them. Let's have fun together.
This time, I would like to do an electronic work that acquires images with an IoT camera and saves them to Google Drive. First of all, the overall flow of this work is divided into an overview and 3 main work contents. The video was also distributed in 3 parts. The first was the overview and Google Cloud settings, and the second was the hardware. This time it will be the third one, and it will be software. The content of the software is a program that connects to Wi-Fi at startup, acquires images with the camera, and saves images to Google Drive using GoogleAppScript. This time it is a video to understand how to use GoogleAppScript. Next, as for the development environment, we will create a program using Arduino. The Arduino IDE for this development environment software can be downloaded from the Arduino official website. All you have to do is connect the Arduino IDE to your computer with a micro USB cable and you're ready to go. The ESP32 used this time needs to change the Arduino IDE settings. Here are the settings. First, make sure that the board is ESP32 dev module. When using ESP32, the board setting must be set to this setting. Port is the port the ESP32 is connected to. If you cannot select it, there is a problem with the physical connection, or the OS is not recognizing it properly, so please check. Also, other settings are like this, so please refer to them. Now, let's take a look at the contents of the main program. Here is the program created with Arduino IDE. There is no problem with the file name, so it will be copied and pasted from the Hobby IT site into a newly created file. I will check this program. There are 3 files to create this time, so create them all with Arduino IDE. Create 3 tabs like this. The first file describes the main behavior. The second and third files are only used for Base64 encoding. Therefore, I don't think it is necessary to understand the program itself of these 2 files, so I will only understand how to use them. Therefore, we will understand the program of the first file. Let's take a look at the program. Loading the library first. Use Wi-Fi client secure and ESP camera. This is a standard ESP32 library that can be used, so if you describe it here like this, you can use it without adding a separate library. Next, I'm setting up a global function. This very first part has settings to change. You can use it by changing only this part. Change the settings related to Google Cloud and your home Wi-Fi settings. If you do not know how to obtain the settings related to Google Cloud, please refer to the URL described in the explanation column. Google Cloud defines the information necessary for using GoogleAppScript here. Next, we set the port for the LED. Since I wired to use IO4 and hardware, I set port 4. Next, set the camera port. This is also set to match the content wired in the hardware. Next, set the variables to be used globally. Since it is set globally, it can be used in any function. Up to here are the settings of basic variables, etc., and from the next is the setup function, which describes the processing at startup. Scroll down to understand what the setup function does. First, enable the serial port. This makes it possible to display the log serially, and it is used for understanding the execution status and debugging, such as the execution status of the program and the display of variables. Next, let's start the camera. First, define the port settings to initialize the camera. Since the port number has already been defined according to the wired content, that value is set. Perform initial setting processing and init of the camera. After execution, check for errors at startup. Scroll down. Next, set the status display LED. This port outputs power and displays an LED, so set it as output. Next, perform Wi-Fi connection processing. Set the SSID and password of the Wi-Fi to be connected, and connect. Check the connection status every 1 second and repeat until the connection is completed. Since the loop is exited only in the connected state, the next operation will not proceed unless the connection is established. Once connected, the LED stops blinking and stays lit. Next, it is a setting whether to check the server certificate of HTTPS communication. I am skipping this time. Since it is HTTPS for accessing the Google Cloud, Google will not take over the server illegally, and this time it is only an operation check, so security does not need to be strong, so I skipped it. If you want to make sure that the access URL and server are correct, you can also check the server certificate as usual if you set the root certificate. Next, we will execute the function getCameraJPEG to acquire the camera image created individually. Scroll down to see what this function does. Here is the function, getCameraJPEG. It's very simple. If you suddenly acquire an image with the camera, the color may become a little bluish, so after performing the image acquisition process several times, the image to be saved is acquired. When the image acquisition process is completed, after confirming that there are no errors, end processing is performed and the process is complete. The image acquisition process is functionized in the library, so you can easily acquire images with the camera. Therefore, the image acquisition process ends here. I would like to go back to the original setup function. Next is the process of saving the image to Google Drive using GoogleAppScript. This is handled by the post GoogleDrive by gas function. Scroll down to see its functions. Here is that function. First, connect to Google servers. If the connection can be confirmed, first, body part information, Base64 encoding of image data to be sent, acquisition of data length, and creation of header information are performed. After that, the information of the header part in the beginning of the body is sent. Next, JPEG image data is divided into 1000 bytes and sent. To better understand, let's take a look at the data we sent programmatically. This is the data packet sent. As shown in the figure, the header and body send this kind of information to the Google server. Variables in double brackets are replaced with actual data before being sent. JPEG data in the body must be encoded in Base64. So let's understand why we encode in Base64. First, regarding the line feed in the body part, since the end sign of the packet is a line feed, there is no line feed until the end of the data. Also, the data delimiter is sent with ampersand and equals. Therefore, if the JPEG data contains the same bit string as the character code such as line feed, ampersand, or equals, it will not work properly. Base64 represents all data with a code of alphabets, numbers, and some symbols. Therefore, symbolic codes such as ampersands and equals are not included. Therefore, Base64 encoding is performed to handle the data correctly on the receiving side. As a reference, if you can set a boundary that can identify data delimiters, you don't have to encode with Base64. This is the data for saving JPEG images with Google Cloud API. The boundary is set to clarify the delimiter without encoding with Base64. For the API it works fine here. Just in case, I tried to change the script set in the Arduino program and Google Drive to see if I could avoid Base64 by setting the boundary in the same way for gas, but it didn't work properly. Here is the data format I tried. So, at present, I think the only way to send gas is to encode it with Base64. Return to program. After the transmission is completed, this while waits for the signal reception from the Google server. If there is a response from the server, the information is displayed on the serial monitor and communication is completed. Let's see what it looks like on the serial monitor if the image upload is successful. Here is what is displayed on the serial monitor. Error information will be displayed even if it fails, so take action according to the error content. Return to program. When the communication is completed, the HTTP processing is terminated and this function is completed. We return to the setup function, which is the end of the process. The setup function that is executed when the Arduino starts up ends. After this, it moves to processing the loop function, but there is no processing. This time the image is fetched and saved to Google Drive at startup, so there is nothing to do during startup. This concludes the description of the program. By writing this program to ESP32 and starting it, you can acquire images with the camera and save them in Google Drive, as you saw in the overview video. Also, check your Google Drive folder. This concludes the content of this work.
We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.